In the name of Almighty God, hello everyone. I hope you're doing great. I hope you're the best of spirit and health. In this video, you're going to be talking about the Singleton design pattern. Yeah, the Singleton design pattern, which is one of the most popular design patterns, and we're going to talk about design patterns in the first place. What are design patterns? We can have an overview of the different types of design patterns, and then we will elaborate on the Singleton pattern, use cases, and a simple implementation in Python. So without further ado, let's get right into what are design patterns in the first place. So design patterns are essentially reusable solutions to common problems in software design. You know that whenever we're making software, whenever we're developing a new software, it's highly recommended. We can say that it's like a must to first go through the design phase. After we gather the requirements, we should design our software. Which classes are we going to have, which components, the relationships, and then go to coding and implementation. Yeah, there is a model called Big Bang model that you directly go to code, and I think that's what most of us, some lazy programmers do, directly going to coding, but that's never recommended and never professional. So we should do a design phase. We should first design and then go to coding and implementation. So whenever we're designing software, we might encounter into different scenarios and different problems, right? There are some specific scenarios that we may run into, some problems, right? And there might be like a number of different ways that we can solve these problems. Okay, so the fact is that we're not the first programmers, most probably, right? We're not the first programmers running into the same problem. Tons of programmers, over the years have encountered the same problem, and they've analyzed the different ways that as I said, there might be different ways to solve it, right? So they've analyzed the different ways that they could have solved the problem, they could have approached the solution, and they finally come up with the best ways, the best practices to do that. And that right there is actually what we have in the form of design patterns. Reusable solutions to common problems in software design. So they represent, best practices that developers can use to solve specific types of problems that frequently occur during the development process without the need to reinvent the wheel. So basically, by understanding and learning design patterns, applying them appropriately, what we will achieve is that basically we will be loaded with years and years of knowledge and experience of programmers, and then we will not need to reinvent the wheel and lose time in thinking how to solve this problem, how to approach a solution, since the same thing has been encountered by programmers. They have talked about it in detail and found the best solutions. So in the form of design patterns, you should just learn these patterns and use them to solve the problems, to address the scenarios appropriately, efficiently, and easily, without losing time, quickly, easily, and in pretty efficient manner. So that's, design patterns. As I said, they represent the distilled wisdom and experience of software developers over many years and projects. So basically, you're going to be loaded, with years and years of programmers' knowledge and experience, and you can simply find the solution for the problem by learning design patterns. Okay, so let's move on to types of design patterns. Design patterns can be broadly categorized into three different types: creational, structural, and behavioral. I think the names are pretty, clear, without, any additional explanation even, right? So creational patterns, as the name suggests, they deal with object creation mechanisms, trying to create objects in a manner suitable to the situation, right? So if I just put it in a nutshell, right? Creational patterns, they talk about object creation, how to create objects in different situations, in different scenarios, right? Structural pattern, they deal with object composition, or the ways to assemble objects to implement new functionality, right? They talk about, object composition, how to structure objects, how to put objects together, and how to assemble them, right? As the name says, structural. And finally, behavioral. So simply put, they talk about, the communication between objects, the algorithms and the assignment of responsibilities, how how do the objects communicate and share responsibilities between each other, or I should say among one another. So that's discussed by behavioral patterns. Okay, so this is just basically a very high level overview, and just the tip of the iceberg, right? We're only touching the surface. They have a lot of detail if you go deep into, but just simply put, creational patterns, they deal with object creation, right? And examples include Singleton, factory method, and builder. And that's exactly what we're going to talk about in here. Singleton is a creational design pattern. It talks about how to create objects, right? So we have structural patterns. We deal with object composition. And these are some popular examples, and there are many, many more, like adapter, decorator, facade, and behavioral patterns. As I said, they're concerned with communication between objects, assignment of responsibilities, and all. And some famous ones: observer, strategy, and command. So this is a very high-level overview of types of design patterns. So now, let's get to the main business: Singleton design pattern. Okay, so the Singleton pattern ensures that a class has only one instance and provides a global point of access to it. This pattern is useful when exactly one object is needed to coordinate actions across the system. So Singleton is as we saw right now, is a creational design pattern, right? It talks about how to create objects, right? So this pattern this talks about scenarios when we need one single object, right? A class should have one single object, and that's one single object should be accessible everywhere. It should have a global point of access. So whenever we encounter such a scenario, right? So we can use the Singleton design pattern. Okay, as I said, reusable solutions to common problems. Whenever you encounter such a scenario that you need a single object that should have global point of access, global access and such. So then there's no need to think about like how to solve the situation, right? Just if you have knowledge of design patterns, you can simply know that, okay, that's the Singleton design pattern. I can just implement it as a Singleton and done. Okay, so the main point: a class has only one instance, no more, and provides a global point of access to that. Okay, it's useful whenever we need exactly one object of a class. So let's have some real life examples. Like, imagine a government issuing only one passport to each citizen. Isn't that Singleton, right? Each citizen can have only one passport, right? And that passport is unique, and it can be accessed globally by its owner. So that's like Singleton, right? Only one passport, one instance, global point of access. So let's have a more example related to computers and all. It's also like a real life simple example, not going into the details of development and all. That there are some apps, right, that allow only one instance of them to be opened at once, while others permit multiple instances running at the same time. So you might have noticed, like, if you have, like, let's say a football game, right? For example, eFootball or whichever game you like. So these apps, you're running them in your computer, right? You get out of the app and you go back and try to open the app. You're just gonna open the same instance, right? You're just gonna open up the same instance, the same window of the app. It doesn't allow you to open a second instance, right? Play one game in one instance and then have another game in the other. That's not possible. But we have other apps like Word, Microsoft Word, right? We open a tab in a sense, and then if you go and click on another Word file, so that's gonna open another tab and another tab. So we can just alternate between among them, and no problem, right? So those apps that allow only one instance, so they're Singleton, right? That's a very simple example of Singleton, that they allow only one instance. And then look at global point of access. Whenever you try to open the app again, it's gonna open the same instance. You're not gonna get it. You don't have a chance to open a new instance, right? But there are the other apps that allow it. So, like as I said, Microsoft Word on desktop, okay? However, Word Mobile, Word Mobile is Singleton. If I open Word Mobile and then I go and, go to my file manager or somewhere and then try to open another file, it's just going to open in the same tab. The previous file will close. So Word on mobile is Singleton as well, but not on desktop. on Mac OS or Windows, right? So these were some simple examples, but let's go into some use cases. Some more examples, detailed examples in actual development and implementation. Where can we use this singleton? So one very important example of singleton, I'm going to go through these quick without taking too much time. So one very important example is resource management. Resources such as database connections, file handles, network connections, they're finite and expensive to create and maintain. The singleton pattern helps manage these resources by ensuring a single point of access. So let's, for example, focus on the database side, right? For example, just going back to the football game, right? The football game, different parts of the app must communicate with the database, right? If the app should sync your account to the cloud so that you can, access it on different devices at any time, right? So different parts of the app, to achieve that purpose, different parts of the app should communicate with the database. For example, you sign a new player, you win a match, the stats should be updated, then you get coins, you use coaches, whatever. So there are different parts of the app that should always have a connection to the database, right? Whenever you achieve something, you win, you lose, whatever, they should commit the changes to the database. So now imagine we, in terms of while developing the app, we just, make a new connection in each of those places. Let's, for example, say that there are 10 different places that should have connection to the database. So in all those places, while development, we've developed the app such that they create a new connection to the database. So can you imagine the strain that's going to that is going to end up putting on our database, right? So for example, one user will have 10 connections to the database. And you just multiply this basically. If you have 10 users, if you have 1,000 and 1,000,000 users, how many connections would that be? That's just going to kill our database, right? You're going to need such powerful servers and, things like, distribution and scalability, all for nothing. Why? Because you could have implemented that as a singleton. So inside the app, you could have coded it that each and every user, while using the app, only one connection, right? You could have coded up the database connection as a singleton, right? As a singleton, and then, that would have been only one instance, global point of access. All the different parts of application would have access to the same connection to connect to the database, commit changes, and all, no problem. So in that way, you have 1,000,000 users, 1,000,000 connections. But in the previous instance, it would have been times 10, 10 million connections, right? So, that's a very simple, but I guess pretty clear example of why the singleton pattern is such a good and useful pattern, right? Resource management. So the same could be said, for file handles, network connections, and all, right? They're finite and expensive to create and maintain. So that's why singleton ensures that there's only one and provides a global point of access to that. Okay, so let's move on. So the other scenarios, the other use cases are similar. The other one is logging. Okay, so it's a common scenario where we can use the singleton pattern. It's really beneficial and advantages. So, for example, back going to like an app. They all talk about apps, right? So we should give examples in terms of apps. So we have a multi-threaded application, and there are different parts of the app that should log what they do, right? Whenever they do something or there's a problem or something, they should log it, right? So if we implement, the logger class just as a simple class that the different parts of the app will instantiate and create a log, then that's, with all due respect, just a stupid idea. Since this will end up, with all the different parts of app creating different log files, right? So there's one part of the app creating one log file, the other part of the app creating another log file, and then what you're going to end up is basically a ton of different log files. So that's just not useful. So what we want is that we want one log file, right? The app should, log all the things related to it in one file, all the different parts, right? So this happened here at this time, this happened here at this time, right? So that can only be achieved if you have a singleton logger, right? If you have a singleton logger, so that means that we have one single logger, one single instance of the logger, the logging class, and it has a global point of access. So whatever a part of the app wants to log, it's going to access the same instance and then log whatever it wants to. And then the other part will access the same thing and then log it, right? So that's, an actual logging, since we're going to have one log file in a sense. And then, they're going to be in order. It will preserve the log sequence and prevent any conflicts, right? They're going to be in order, so this part of the app happened at this time, and then this part of the app, this thing happened at this time. That's, a real logging experience, right? So this is a common scenario where you can use the Singleton design pattern, right? So if you don't use Singleton, then basically each part of the app will instantiate a logger of its own, and then you're just gonna end up with a pile of log files, right? But like this, you have one log file, and all the different parts of the app using it, and it's gonna preserve the log sequence. That's really important, right? Which is just not possible without using Singleton. Okay, so a final example would be configuration settings, right? In many applications, configuration settings are stored in a single file or resource, and the Singleton pattern ensures that the settings are read once and shared across the application. So you can read these examples in here, the slides yourselves, but I'm just going to give you a simple example, right? So settings app, right? Settings app is one of the things that, it must use Singleton, right? You should only have one instance of the settings app. So for example, right now, if I just go to my settings, if I were able to make open multiple instances of the settings app at the same time, so I'm going to open one instance and, tune a setting as I need, right? Let's say I'm going to turn off the audio, and then I'm going to open another instance, and then I'm going to turn on the audio in that one. So if both of these instances basically are, in a sense, if they were not Singleton, right? If they were functioning at the same time, so then other external apps know which one to obey, right? It's much like you have two commanders and they're giving you opposing commands. So what to do, right? One says audio is off, the other says audio is on. So that's a big problem, right? So how to solve this problem? Singleton. Configuration settings should be Singleton. We should only have one instance of the settings app. So basically, if it's a settings app or it's a file or whatever, right? We should have only one instance of that, and we should have a global point of access. Only one instance, and all the different parts of app, wherever, accessing that instance, and that's exactly the true definition of Singleton. So it could be, as I said, settings, or basically when we have configuration settings like database connection string, API keys, and other global settings, right? So you should use Singleton class so that they're all stored in the same place in one instance, and all the different parts of application are accessing that only one instance. And that's just going to be really good. And that's also good in terms of maintainability and, future evolution. It's one instance, right? So you can change that, and it's going to be reflected across the whole system, rather than having multiple instances and then go and change every one by one, right? So these were some example use cases of the Singleton, resource management, as we said, configuration settings, and what was here? Resource management, configuration settings, and one more example that we had moments ago. I remember logging. Okay, so as we said, let's conclude this video with a simple implementation of the Singleton design pattern. So it's the database connection, right? So implementation basically, so when you know the idea, so then implementation is basically a matter of language. When you know the idea, when you have the experience, and you know the language, then you can just implement it in whichever language you want. And now we have all sorts of support from the internet, whether you want ground support or you want airstrike, it's all available at your fingertips through AI systems like ChatGPT, Copilot, whatever. So I'm just gonna have a simple example in Python of a Singleton database, right? The database connection, as we said in the first example, resource management. So one example was database. So this is how we can implement a Singleton, right? So the main point is that we should have one instance and a global point of access. So how can you do that, right? So here's an example in Python. So we have class database connection. So what we do inside this class, that we store the instance in a variable. So first we call that instance variable literally _ instance, right? So at the beginning it's none, right? We don't have it. the instance is none. So inside this class, so this is just basically Python syntax, and I'm just going to explain it, and you can, if you want more explanation, you can just put this into ChatGPT or Copilot. So inside this class, we're coding it as a singleton. What does this mean? It means that it should only allow one instance. This means that, we are storing the instance in a variable, and then we are checking. If this is not none, right, it means that we have an instance, so just return that instance, right? So look at this new function. This is one of the special methods in Python, as we know, methods that have double underlines on both sides. They're called like dunder methods. They're special methods in Python. So this means that whenever we create a new instance of this class, so do these things, okay? So first check if this is none, right? If we haven't created any instance yet, so move on and create one, right? Move on and create one and return whatever you've created. But so basically, look at if class.instance is none. If we have not created, then go and create one. But if we have created one, so just return that. So that's exactly how you can ensure that we can have only one instance, right? So if this is none, we should first initialize a variable to store that instance. So then we check whenever you're creating a new instance. If it's none, if we have not created yet, so go and create it. It's just Python syntax to do that. Just instantiating the class within the class. So the syntax is going to be different from doing it, in normal, runtime, right, in program. So it's like this. So we go and create an instance of the class. We instantiate it like this using the super function dot new class, and then we store it to the same class instance, right? And then we can call the function that we have. So it's database connections. You can call the initialize connection, which is basically simulating that. So you should use a library and all, and provide host and basically password and all, whatever. So that's initializing the connection, and then we return the instance. If it's not created, so we create one, we do whatever else we want to do, and then we return it. But so now it's created, right? It's created in here and assigned to this class variable. So the next time, so that's when one class, when it's when the class is instantiated the first time, right? So this happens. It's created and then it's passed to this variable. And then the next time when basically another part of the app tries to create an object of the same class, of the singleton class, then it's just going to come here and check, okay, the instance has something, and then it's going to return false, and it's not going to create a new one. It's just going to return whatever it has in place at the moment, okay? So that's how we can implement the singleton pattern, right? So you just check that if we've created an instance, so just return that. If not, to create it, then save it, so that, and then check in the subsequent creations, instantiations, and make sure not to create a new one. Just return the same one. So that's how we can ensure we're gonna have only one instance, and basically thereby providing a global point of access, right? When an instance is created, the next time basically, whenever we want a new instance, it just basically returns the same instance. It doesn't create a new one, right? Now these are basically just vanilla database connection methods, just simulated, right? So initialize connection and provide all those things, and just a query method, right? So in a sense, running the query. So now let's go and see this in action now, right? So like, imagine this is one part of the app. It creates a connection to the database, and this is another part of the app that creates a connection to the database, right? Instantiates the database connection class. So one part, db1.query, so it works, it runs a query, good. And then the other part, it also runs a query, good, they work. But, so are these two different connections? No, since our class is singleton. The first one, whenever it's created, okay, it comes and checks, we don't have an instance, it creates it, but then assigns that to instance, to this underscore instance variable, right? And then when the second db2 connection instance comes in, so it checks that, is it none? No, it's not none. So return the same instance and don't create a new one. So we have the is operator in Python, right? So the is operator is used to check, identity, whether two objects are the same, right? Exactly the same objects. So we know that object is stored as a reference, right? Object is stored as a memory reference. So whenever you want to check it, we shouldn't use equality for that, since equality is not for that. It's more like for simple data types that are not reference data types, value types that store the value directly, string, integer, things like that. But objects are reference types, right? The value is not stored directly, but I mean, they're not referenced like that directly through their value, since they're more complex. They're referenced by their memory address. So we should use the is operator. So that checks identity. For objects, basically checks if these two different objects are referring to the same instance, right? To the same memory address. Okay, so object is stored as a reference, as an address. So it's like a hex code, right? That's somewhere in the RAM, right? So this DB1 is created and is represented as a hex code, which just shows that where it is in the RAM, right? So that's why it's a reference type. That's what's stored here and visible to us whenever you say print this object, right? So it's just a hex code and of the memory address where it is stored in the RAM in the memory, right? So for comparing that, so to know that whether these two are the same, you can use the is operator. That checks identity. That checks if these two have the same reference, right? The same address, meaning that these two different objects are actually referring to the same object. It's just one object in two different formats, right? So if we do this check, this identity check, that returns true. Okay, so db1 is db2, that'll gonna output true, which clearly showing that our singleton class is implemented successfully, and we really have one single object, global point of access. And so just go on and create how many objects you want. They're all gonna refer to the same instance. We actually have one instance, right? We're not gonna have more than one instance. They're all going to be referring to the very same instance, the very same address in memory, and that's the singleton pattern. So I hope this video was clear, and I hope I have provided a clear explanation of the singleton pattern. And as I said, you can always use ChatGPT, Copilot, and the like for more explanation, for more research on the topic. And with this, I want to conclude this video. Thanks for watching, and goodbye. Peace out.